Let's see the next question next. Write the following functions in the simplest form. What are we supposed to do in this? We're given this function which looks pretty complicated. Yes, this looks pretty complicated. You have a tan inverse, which is in itself a difficult thing. And then you have the under root of x square, 1 plus x square minus 1 upon x, a complicated expression. Can this be simplified into something else? Let's see. Okay. So what are the hints that we have in the question itself? X is not equal to 0. Okay. So there are no limits on x related to minus 1 and 1. Okay. So possible substitutions could have been x equals sine theta, cos theta, tan theta. And if you observe this x is not equal to 0, it implies that maybe sine theta and cos theta will not work over here, tan theta works over here, since x is lying in an interval beyond minus 1 and 1 as well. Okay, so x equals tan theta may work, right? And you can realize that by looking at this as well, this is 1 plus tan square theta, which is x square theta, and can be simplified in terms of the square root. Had there been 1 minus x square, you would have thought of sine theta and cos theta. But since this is 1 plus x square, we'll have to think in terms of tan theta, right? So the substitution that we are going to make is x equals tan theta, or let tan inverse x equals tan theta, tan inverse x equals theta, which actually give me x equals tan theta, right? This is what you get. Okay. Now what about this x? It is given that x is not equal to 0. That's the domain of this. It is given that x is not equal to 0. Therefore, theta will not be 0. That's a simple thing. Yes. Anything else? No, nothing else. Theta lies in some interval. Minus pi by 2 is less than x is less than, sorry, minus pi by 2 is less than theta is less than pi by 2, except for theta is not equal to 0. With the help of this, you can note that tan inverse x, the output of tan inverse x is from minus pi by 2 to pi by 2, open intervals, right? Therefore, theta lies in this interval. But theta is not equal to 0 based on this. That's okay. That's okay. So once you have noted this, therefore, the expression tan inverse under root of 1 plus x square minus 1 whole divided by x becomes equal to what? This expression becomes equal to what? Now comes the answer solution. Tan inverse of under root of 1 plus x square will become under root of 1 plus tan square theta minus 1 whole divided by tan theta. What else? 1 plus tan square theta, this will further simplify to 1 plus tan square theta is sec square theta, under root will be sec theta minus 1 over tan theta. Okay, this looks complicated. Can this be converted into tan inverse of tan something? Can this be converted in terms of tan? That's a question. Tan of some angle, yes. Let's try to do that. Let's try to do that. Inverse of sec theta is actually 1 upon cos theta. Let's try to simplify by multiplying cos theta, since this also has a cos theta in the denominator. This is 1 minus cos theta over sin theta. What I've done is multiplied numerator and denominator by cos theta. So this becomes cos theta times sec theta, which is 1, minus cos theta times tan theta, which is sin theta. What else? Now, I can convert 1 minus cos theta and sin theta in terms of half angles. Yes, benefit of converting into half angles would be this. 1 minus cos theta can be written as 2 sine square theta by 2, and this can be written as 2 sine theta by 2 cos theta by 2. Okay. So therefore, this is tan inverse 2 gets cancelled, sin theta by 2 gets cancelled, and what you get is sin theta by 2 upon cos theta by 2, which is actually tan theta by 2. And what happens in this case? Tan inverse tan theta by 2. If theta lies in this interval, theta by 2 will lie in a more restricted interval, that is from pi by 4 to minus pi by 4 to pi by 4, and in that interval the definition of tan inverse tan theta, tan inverse tan x will be x only, that is theta by 2. What is theta? Theta is something that we started with. Theta is tan inverse x. So this is 1 by 2 times tan inverse x. That's the simplified version of that. This is the answer for that question over here. That's the simplified version of this expression. That's the complete solution. Let me get a side so that you can take a look at this. With this, we come to the conclusion of this question.